All right, so we are going to talk about voltage and electric fields quickly. So, first of all, let's look at the electric field of a single charged particle. This particle is positively charged. I don't know what it's positively charged with. Maybe let's pretend it was 3 microcoulombs. I very clearly need a new Sharpie. If it was charged positively with 3 microcoulombs, what that means is that 3 microcoulombs worth of electrons are missing from it. Okay, remember, I'm not positively charged because I gained extra positive things. I am positively charged because I am missing negative things, and those negative things I am missing are in fact electrons. So I have this thing that I say is positively charged, and we're going to talk about the field for a second here that is around this. So first of all, I know that the field points away from this. And I know that if I had a second particle, let's call this second particle Q, that let's call it Q2, and we'll call this one Q1. I know that the force between these two particles would be K Q1 Q2 over R squared, where R is simply the distance between the centers of the particles. So I have these two positively charged particles, and the force between them is Q1, Q2 over R squared. It doesn't matter if you get a positive number or negative number, because we're going to use common sense, and we're going to say if they're both positive, they repel, and if one's positive and one negative, they attract, and if they're both negative, they repel. We're going to use common sense. And then after you use common sense, you can say to yourself, oh, that's why that's negative. Oh, that's why that's positive. This is what negative means. This is what positive means. So now that I know how to calculate the force between them, I also know that each of them has its own field, just like the Earth has a field. And if you remember, the Earth had a gravitational field. And so if this were the Earth, and this was a mass on the surface of the Earth, we hung the mass, we found the force due to gravity, and we divided the force due to gravity by this little mass to find the field strength on the surface of the Earth. Well, we do the exact same thing to find the field strength at any distance between these two particles. So this particle is this far away, and we say, okay, what is the field strength due to charge 1 on Q2? So if you pretend that charge 1 is the Earth, then what am I doing? I'm taking the force on this particle and dividing by that particle. Just like we took the force on the mass and divided by the mass. We didn't divide by the Earth information because we wanted to know the field strength due to the Earth. If I divided by the Earth information, the Earth would go away. So I divide by the other thing because I don't want this one to go away. So if I want to know the field strength due to charge 1, I'm actually going to divide by charge 2. And just like field strength for the Earth, on the surface of the Earth was the force on that mass divided by the mass, the electric field strength due to Q1 will be the force that you calculate divided by Q2. Now, sometimes, well, hello, cat. Please get out of here. Sometimes they don't give you a Q2. They simply say, what is the electric field strength some distance away? What did I tell you you do when you don't have a mass? You make one up and you get the exact same answer. That's also true here. Without using numbers, I'm going to show you why that's true here. That's true here because you find the force, Q1, Q2 over R squared. So there's your force. This is how you find the force. And then you divide the force by Q2. I know I'm using a different Q, sorry. In order to find the field strength. Sorry, you can't see that. That's too low. Let's just drop this down a little bit. There we go. You divide it by Q2 in order to find the field strength, right? So Q2 goes away. So if you want to know the field strength due to Q1, you can do this. This is not on your reference table. That's not on your reference table. Why is it not on your reference table? Because they are expecting that you have the ability to put two equations together. And those two equations are this F equals K Q1 Q2 over R squared, and that the field strength is F over Q. Okay? They're expecting you can put those two things together. Again, what's really important is if I say, what is the field strength some distance R? Go away, cat. What is the field strength some distance R away from Q? It's really important that you recognize you're not dividing by this Q. You're making up a different Q that's right here, just like we had some mass when we had the Earth and we were finding the force on that mass. You're finding the force on some other charge because of this charge that they're asking about. So this other charge goes in this equation and then gets divided again. So if you put these two things together to find the field strength for this charge and just this charge, the other charge that you made up is going to disappear. It's just going to go away. It's not there anymore. And so when you put those two equations together, you end up with just this. If I want to know the field strength some R away on some because of some charge, it's just this equation because I put these two together. All right, so you need to be able to do that. You need to be able to take this equation, you can make up a number, or you can recognize that when you put them together and you can practice putting them together, that they cancel out.